welcome everyone on the call. Welcome to the BCS Leicester branch event for March 2022. This month, it is our absolute pleasure to introduce a talk on an introduction to network subnetting, subnets, IP addresses, and subnet masks. Our speaker this month is, Glacia Evangelidou, who is, just get this right, so Glacia is Networks Operations Manager for Historic Environment Scotland. She holds more than 18 years of extensive and diverse experience in the IT industry and as a certified network engineer. She's managed complex networks, including RAN and data center environments, and I'm absolutely certain she's going to teach many of us new things tonight. So I'll very happily hand it over to Glacia and look forward to your talk.
Hello, everyone. Welcome to this presentation. Tonight, we're going to talk about networks, IP addresses, networking, subnet masks. This is a webinar for beginners, so everybody is going to, I hope everybody is going to understand what we're talking about. And I hope that this proves of value to all of you, because networking is not all about network engineers, but all these topics we're going to discuss tonight are going to be very helpful for people working with servers, people working in security, and even service desk people. And let me begin my presentation asking a question to you, and you can pop your answers to the chat. And please allow me to switch off my camera first, because I would like to ensure that my connection stays stable throughout the whole presentation. So this is the question I would like to ask you. Can you recognize a valid IP address? So what would you say? Is this a valid IP address? Yeah, I'm happy to see that. Yeah, there are some of you recognizing that this is a valid IP address. So I'm going to put a check next to it. What about this one? Does it look like a valid IP address? No. Yeah, that's right. That's not a valid IP address. This one? Yes, this is a valid IP address. What about, let me try a trickier one, this one. That's correct. This is not a valid IP address. This one? Yes, yes. I'm glad to see that some of you could recognize the IP addresses. So just to make sure, this is a valid IP address and this is a valid IP address. But I'm pretty sure that we are all at the same page. So the easy way to recognize a valid IP address from an invalid IP address is these numbers here. So whatever exceeds 255 on each of these spaces is not a valid IP address, and we're going to discuss about this later. So let me jump onto the next slide. Let's see some fundamentals about IP addresses. IP stands for Internet Protocol. So an IP address is part of the TCP/IP suite, and IP stands for Internet Protocol. It consists of 4 octets, and it's got the form of something. So something dot something dot something dot something, and all these somethings are numbers up to from 0 to 255. And each section is called an octet. So 4 octets, each octet is equal to 1 byte. So we have got 1 byte here, 1 byte here, 1 byte here, and 1 byte here. And as you may know, 1 byte equals to 8 bits. So it's 8 bits here, 8 bits here, 8 bits here, 8 bits here. And all of it, it's got a length of 32 bits. But why do devices need IP addresses? Could someone pop it in the chat, and I'm going to answer the question. All the devices that need to be connected to the network need an IP address because apparently they need to communicate with other network peers in another network. And what do I mean by that? When all the devices are in the same network, actually they don't need an IP address because they can communicate using their MAC addresses. But if a host want to communicate with other hosts belonging to a different network, they do need an IP address. I hope this makes sense to you. Let's go to discuss private and public IP addresses. In the networks, we have separated the ranges in public and private ranges. And the private ranges are all hidden behind private networks, your home, your workplace, the universities. Each private entity has got a private range on their network. But on the contrary, web servers, internet service providers, other network devices that need public IP addresses, all these hosts, all these devices in need of a public IP address, all of them are part of the internet. So they are visible on the internet. The private ranges, we have got 3 different classes. Actually, it's not only 3, it's more than 3, but we're not going to talk about the other 2 classes because they are for very, very particular reasons, scientific reasons, so we're not going to analyze those. But we have got 3 classes for our private networks. Class A is the range of 10.0.0.0 up to 10.255.255.255. And as you can see here, this class can give us 128 possible networks, and each network can host around 16 million devices. That means this is a very, very big network. Class B is the range of 172.16.00 and up to 172.31.255.255. And this class can give us around 16,000 possible networks, and each network can host more than 60,000 devices. So again, this is a very, very, very big range, big networks. Class C, it's the range of 192.168.0.0 up to 192.168.255.255. And you can see that this range can give us around 2 million possible networks, and each network can host up to 256 hosts. So you can imagine that our home networks provided by our ISPs quite possibly are on this range. So if you investigate, if you try to discover what's the configuration on your home network, quite likely is going to be on this range. So your computers at the moment have got an IP address of 192.168.0. something here, okay? And I'm going to show you about this later. And as I said before, the public ranges are all the rest. So for example, one very well-known IP address we use in networks to test our internet connectivity is one of Google's DNS servers. So this DNS server is on this IP address 8.8.8.8. So you can see this this IP address here does not match any of these requirements on any class, so it's a public IP address. Let's move on to the next slide. And I'm not sure if you're happy to see this, but we're going to discuss a bit about the binary system. And I'm going to give you I think this is a nice analogy to try to analyze and describe the binary system. So let me allow me to tell you a little story here. And we have got the lockdown market. I have named this this shop the lockdown market because they sell IT kits. So it's webcams and headsets, microphones for companies to try and survive throughout the lockdown. And we have got Jen here and Ben. And Jen is the cashier, so she receives all the orders from the customers. And Ben is the guy to go to the storeroom and fetch all these boxes for the customers. So we have got the first customer here, and he has arrived at the shop, and he's asking for 210 boxes. The shop has just opened, so they haven't thought about the system yet. So what do? Jen calls out the order, and Ben goes behind to the storeroom and grabs a box, brings it to the front, and then goes back, brings the second box, and then goes back, brings the third box, and he does this job for 210 times. He needs to carry one by one all these boxes here. And you can see, yeah, okay, the first customer needs to wait for some time for his order to be fulfilled. The second customer does not look very happy. The third customer is a bit frustrated. So they have thought about this very wisely, and they have decided to introduce a system to make their job easier and keep the customers happy. So what do? They have decided to introduce palettes. So they have got a palette of 128 boxes, another palette of 64 boxes, 32 boxes, 16 boxes on another palette, 8, 4, 2, and 1 box. So this customer, the first customer who needs 210 boxes, they give him some flags to put on the palette. So the order is for 210 boxes. So apparently he needs to put a flag on this palette because he needs 128 boxes. So what's left? He put his flag here, and then he's left with 2, 3. So he's left with 82 boxes more. Apparently, he needs a palette of 64 boxes. So minus 64, he needs another 8. he needs another 18. So 0 flags on 32 because he cannot have, he needs another 18 boxes. So he doesn't need 32 boxes, no flags here, but he will put a flag here, 16. And he takes away 16, 2. So no flags here, no flags here, a flag here, and no flags here. So what they just did is an application of the binary system. If you replace the flags with ones, so the decimal number 210 in binary is 1, 1, 0, 1, 0, 0, 1, 0. Let's save some time and not do 120. Let's do 15, which is very, very easy. So the customer who needs 15 boxes, no flags here. So it's a 0, no flags here, 0, no flags here, no flags here. He will put a flag here, so 8 plus 4, another flag here. So it's 12 overall, plus another 2, 14, plus 1, 15. So the decimal 15 is 4 ones in binary. And that's how binary works. But I'm guessing one of your questions is what all this has to do with networking. And let me explain by jumping onto the next slide. If you put flags in all of these palettes, so it's all ones, we have got 8 ones in total. 1, 2, 3, 4, 5, 6, 7, 8 ones. This number in decimal, 8 ones, 8 binary ones, makes the decimal 255. And this is the maximum, the highest number you can get in a network octet, in an IP address octet. So the maximum number here can be 255, 255, dot 255, dot 255. And this is why I'm going to get you back to the first slide. Sorry. This is why we could easily recognize the invalid IP addresses. This one and this one have got octets which exceed the number of 255. So let's say, for example, here, here, and all these numbers here. But none of the valid IP addresses exceeds the number of 255. And that's an easy way to recognize a valid IP address. Let's go back here. Yeah, we have covered this. Let's go to subnetting. Now that we know what a valid IP address looks like and how it's formed, let's create a scenario that we have got an HQ building, and the network architects have given us this range to distribute to all the departments of the company. So the architects have decided this range, and the network engineers need to configure the network devices and apply subnetting to the different departments and form the different networks. So they start from this team, the marketing team, and they start from the first, the beginning of the range. So it's 10.0.0.0. And they have decided to go, so they will use this, they will use this octet to, sorry, something goes wrong with my pen. They will use this octet to, to separate all the different subnets. So it's 10.0.0.0 up to 10.0.0.255. Easy one, because they have used all the 255 numbers available here. And they are going to jump to the next octet. So for accounting, it's going to be 10.0.1.0 up to 10.0.1.255. Could anyone do the rest in the chat just to make sure that you can follow me? And I'll do it at the same time with you. So for HR, the engineers are going to give 10.0.2.0 up to 10.0.2.255. For IT, 10.0. Yeah, correct. Dot 3.0 up to 10.0.3.255. Finance, I guess you guessed right. So it's going to be 10.0.4.0 up to 10.0.4.255. And this one is going to be the 5 range. So 10.0.5.0 up to 10.0.5.255. Thanks. Is it Anil pronounced? Thanks very much. Yeah, that's right. So what we notice here, the network engineers have given each team, each department, a range that is able to host up to 255 devices. 255 devices for marketing, 255 devices for accounting, a capacity of 255 devices for HR, and the same capacity for all the networks. And they have saved the .6, so 10.0.6.0 network and 10.0.7 network for future implementations. So they have saved 2 ranges of 255 and again 255 for, let's say, Wi-Fi or other implementation. Yeah, Anthony, I'm going to answer to your question on the next slide. Is leaving 2 subnets empty as resilience enough? It might be enough for their plans, but it might not be enough. So this way of doing subnetting is the easiest way of doing it, but it's not the most efficient. Okay, so I mean, eyes blindfolded. It looks very easy, but they have done what? They haven't taken into consideration the size of each subnet. So they have just given a flat capacity for each team, which might not be a very good idea with regards to resilience, as you said. So let's sorry, let me answer this question. Why do we need subnetting? So why did we not just take this range and just said, okay, let's start from 10.0.0.0 up to 10.0.7.255 and give them all the same range? This is for 2 reasons. Reason number 1 is security. We don't want marketing people to be able to communicate with devices belonging to HR. We might not want accounting people to be able to communicate with devices in research or finance. Another very, very important reason is in networks, we have got a term called broadcast domain. What does this mean? Imagine that this is a network. So we have got a router sitting here somewhere, and we have got a switch or multiple switches. Okay, so a circle with a cross in is how we symbolize a router, and a box with two arrows is how we symbolize a switch. So the switches, if we configure the network with a single range of this size, imagine that whenever a device wants to send broadcast packets into the network, these broadcast packets are going to reach all the hosts, all the network components in a single network. So what we do, we segment our networks in order to minimize this broadcast traffic reaching all the devices. So whatever broadcast is happening in the marketing department is going to be heard, and heard, I'm going to put it in quotes, okay? It's going to be heard in this range. Something from this range cannot broadcast any traffic to the other ranges. So what we achieved this noise, let's say this broadcast noise, to be maintained with within this range, okay, and avoid unnecessary traffic all across the network. So that's the two main reasons of subnetting. Let's go to the next subject, which is subnet mask. Sorry, I've got a question here. I suppose a broadcast message is like shouting into a group of people to find someone when you don't know where they are. That's very correct. Everyone gets the message, you find them, but it's not very efficient. Yes, Thomas, thanks. That's very true. Yeah, whenever a device in the network wants to send a packet out but doesn't know the exact location of the destination, shouts out the destination, and whatever device holds the IP address or the MAC address that the originating device needs, it sends a bit back and to say, yeah, hey, I'm here, you can send me now. But the initial packet needs to be a broadcast because the originating device doesn't know where to send this packet. So yeah, imagine in a very, very big network, somebody to shout out the destination. Yeah, unnecessary traffic. Subnet mask. The subnet mask is this very important piece of information that we need in order to specify how big the network is. For example, let me give you an example here. 10.0.1.1. And I've got another IP address, 10.0.1.50. So you can see this octet is the same, this octet is the same here. The only thing that changes is this octet. So somebody not very into networks might say, okay, these two hosts, these two computers, quite likely belong in the same network. Can we say that? Can we say with certainty that this dot one device belongs to the same network with the 50 device? No, we cannot say that because there is a very important part missing from here, which is the subnet mask. So the subnet mask is this piece of information that will tell me if these two IP addresses belong to the same network. And sometimes, let's say I have worked with colleagues in service desk. And yeah, it's fair enough, because service desk team members, fair enough, they don't know everything apparently, and they are not specialized in networks. So they may assume that, yeah, okay, a server, let's say in this IP address, so why can it not communicate with a server in this IP address? It doesn't look too much different. So that's half of the true, let's say, because we need the subnet mask, and the subnet mask will tell us if these two belong together in the same network. And let's work on this example number 1. We have got a network of, let me erase all this from here, 10.0.0.0. And the subnet mask is 255, 255, 255, 0. What does this piece of information tell us? This network, the 10.0.0.0 network, this is the beginning of the range. So this is the network IP address. This subnet mask says that this network, what is the range? This network goes up to what IP address? If you notice yes, Anthony, yeah. If you notice, the octets of the subnet mask and the octets of the IP address are all 4. So this part specifies that the first octet. So 255 here means we need all the bits, all 8 bits. So if you remember from binary, 8 bits is 255. So we need 8, 1, 2, 3, 4, 5, 6, 7, 8 bits here. Another 8 bits here. 1, 2, 3, 4, 5, 6, 7, 8 bits here. Another 8 bits here for the third octet. 1, 2, 3, 4, 5, 6, 7, 8. How many bits here? 0. So all zeros. Sorry, not 0. How many ones? 0 ones. Okay, so 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. If you see here, the definition of the subnet mask includes the ones and the zeros. The ones, and it needs to be consecutive ones, a series of ones. So these 8, 16, 24 ones specify that we need all this. Let me change the color of my pen. This is the network part. So this will remain the same for all my hosts. So my network is the 10.0.0 network. Okay. What about this octet? This octet, if you see, it has got all zeros. So the all zeros, let me grab my blue pen again. The all zeros is the hosts part. So this means that this last octet is going to change because it's the host. These first three octets is the network, and then the host part is going to be from 0 up to what number? Up to 255. Okay, so it's going to be 10, 0, 0, 2, 5, 5. This is my range, and this is the size of my subnet. Yes, Anil, yes. What about this one, okay, you could figure, and I'm happy that you could do it. You could figure the first example. What about this example? Can you see it's, so this subnet mask is a very, very well-known, and it's used maybe most times of every other any other subnet mask. So it's very, very well known to a person that has done a little bit of networking. But what about this one? Let's go to analyze this example. Again, we have got, I deliberately kept the same network just to show you what's the difference. So this is again the same network, 10.0.0.0 network, but the subnet mask is different. So we have got a subnet mask of 255.255.255.128. What's going on here? Again, as previously, we need all ones here. 1, 2, 3, 4, 5, 6, 7, 8 ones. 1, 2, 3, 4, 5, 6, 7, 8 ones. 1, 2, 3, 4, 5, 6, 7, 8 ones. How many ones here? If you remember, I'm going back to the binary system. Here. We need, our subnet mask is not 255, is 128. So we're going to need 1 here and all zeros. Let me go back to my subnet mask. So for 128, it's 1 here and all zeros. 1, 2, 3, 4, 5, 6, 7 zeros. By landing this one here on the 128, so this is 128, okay, this is my 64, 32, 16, I haven't got space for all of them, or maybe I do. Okay, my first, my last bit of the subnet mask landed on 128. So this means that my range is capable of holding 128 hosts. This is the size of my network. So if you go here to the range, my network is going to be, so all 8 bits here. So I'm going to keep 10, I'm going to keep 0, I'm going to keep 0. But here, my range is not going up to 255 as previously, because if you remember, I had all zeros here. But now I have got 128. So my range is going to be 10.0.0.0 up to 10.0.0.127, because my next network is going to begin from 10.0.0.128. Okay, and again, dependent on the subnet mask, you don't know up to what's the maximum IP address this subnet can go, because again, we need a subnet mask to tell us the range. Okay, we're going to do other examples so that you can understand. I don't know, any questions here? So just if you remember that an IP address by its own is only half of the information, we need a series of consecutive ones and zeros to tell us about what is the capacity of the subnet. Let me give you an example, like an example of what is not a valid subnet mask. So let's say 255, okay, 255, 255, 27. Okay, this is not a valid subnet mask. Why? Because as I said before, we need consecutive ones and zeros. What is 27 in binary? 27 in binary is 0, so it's 0 on the 128, 0 on the 64, 0 on the 32, 1 here. 16 plus 8 is, we will need another one here. We will need another one here, and 0, let's say here, and 1 here. So can you see we haven't got a number of consecutive ones and zeros. So this is not a valid subnet mask. We need all the ones to be together and all the zeros to be together. Okay. Let me go to the next slide and let's do this properly now. In networking, we have got a very nice technique which is called VLSM, various length subnet mask. Our previous example of subnetting, it was flat 255 devices for each of the subnets. And we were left only with 2 ranges for future implementations. But this technique of various length subnet mask allows us to do what we've done before, okay, to work with different sizes of networks. The only rule that we need to stick to is we always need to start our subnetting going from the largest subnet to the smallest. So in this example, we can see that the largest subnet here is this one, 68. And again, the range remains the same. The architects have given us this range and they said, okay, go and configure the network using, not going further than this range. So we start from the largest subnet, the research team, 68 devices. This is the requirement. We go, we need to have our binary system next to us. So 128, 64, 32, 16, 8, 4, 2, and 1. Just a small note here. These numbers are not random numbers. These numbers are powers of 2, of the number 2. So if you see here, this is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, and so on and so forth. Okay, these are not random numbers, just I didn't came up with these numbers. Okay, they are powers of 2. 68, we need a subnet of 68. So we're going to start from this IP address, 10.0.0.0. This time we're not going to go up to 255, but we're going to calculate and a bit future-proof our network. If you see here on the binary system, where do we need to land? Where do I need to land my first, my last 1 and my first 0? Can you answer? Yes. Yes, Anil. So my last 1 is going to land here, 128. Why? Because I need to choose from all these numbers my capacity. 32 is not enough, 64 not enough. So what is it, the next best number? 128, okay. And all these are going to be zeros to form my subnet mask and my capacity. And we notice that this first subnet for research is going to be 10.0.0.0 up to 10.0.0.127. Okay, this is my range for research. Let's put an R here for research. Next largest subnet. So we've done research. Next in line is IT, 34. Could you give me in the chat where should I land my one? What number? Yes, Laura. It's 64. Why? You can see binary does not allow so much flexibility. So 32 is not enough, and necessarily I need to go to 64. So this is where I will land my one, and this is going to be again N1. Okay, because as I said before, this is the side of ones, this is the side of zeros. So 0, 0, 0, 0, 0, 0. This is my subnet mask. Okay, so my next range is going to be what? I left from 127, so I need to start from where? 100. Let me go here because I haven't got space. My next range is going to be 10, 0, 0, 128. Okay, up to what number? We said 64. Okay, here. So if you do the math here, plus 64 is going to be what? 10.0.0. If I'm not mistaken, 192, 191, sorry, because this is my next network. So I'm going to, my last host is going to be 191. Okay, sorry. So this is for IT. Next subnet is this one. Yeah. So where do I need to land my my bit of 1? On what number? On 32. Yes, Laura, on 32. So 1, 1, 1 here, and zeros. 0, 0, 0, 0, 0. And these are my subnet masks. I'm going to do the math later. So we have left from 10, 0, 0, 192 up to what number? We need to add here what? 32. So it's 10, 0, 0, 2 to 4, 2 to 3, I believe. Okay, so this is for marketing. Let me put an M here. We have done the ranges, but we haven't done the subnet masks. This first subnet, this first range for the research department, what is the subnet mask? The subnet mask, because I didn't change any of the first octets, so the subnet mask is 255, 255, 255. And what is my subnet mask? My subnet mask is this bit, 128. So this is the subnet mask of this network. What is the subnet mask of the IT subnet, the IT network? The subnet mask, if you see, has got two 1 bits, one on the 128 and another one here on 64. The calculation is, yes, Gary. The calculation is we need to add these two numbers together because I've got a 1 here and 1 here. So if you add these two numbers together is 192. That's correct. The subnet mask, so for this subnet is 255, 255 255 192. And consequently, what is the subnet mask of this marketing subnet? I have got 3 ones here. So I need to add the 32 as well. So 128 plus 64 makes 192 plus 32 makes 255, 255, 255, 224. This is the subnet mask of this subnet. Yes, Laura. Yeah. And that's it. I'm not going to do all of these, but if you can have a screenshot and do it later all by yourself, I get that you got how it works. But I'm going to show you a very, very powerful and useful tool later that it does the job for you, and it gives you the binary information as well, so that you can figure how it works. So let me jump to the next slide. Cidr notation. This is just a different way of communicating the information of the subnet mask. And CIDR stands for classless interdomain routing. Let me go back to the previous slide. As we already know, apart from the IP address, we need the information of the subnet mask. So we say to somebody, oh, your IP address is 10.0.0.5, and your subnet mask is 255.255.255.128. Instead of saying this, we can say what? Let me return here because I need this space to write. So we say, okay, your IP address is 10.0.0.5, and your subnet mask is 255, 255, 255. Let me put the 0 here because it's easier. Instead of saying all these numbers here, it's way easier to use CIDR notation and do what? I am using the ones and zeros in the subnet mask. So here I need 8 ones. Okay, 8 ones here, 8 ones here. This is not, it's just, I'm counting the ones, okay, don't get confused. And 0 ones here. So 3 times 8, in total, I need 24 ones in my subnet mask. And that is my CIDR notation, /24. Okay. Let's go back and do the CIDR notation for the other subnet mask we met here. So what is the CIDR notation for this subnet mask? Can you say? 8 ones here, plus 8 ones here, plus 8 ones here. So all of them 24, plus another one here. So it says, yes, Hamid, yes. This is a /25 network because it's got 24 ones plus 1. It's a /25. What about this? Again, we need 8 ones, 8 ones, 8 ones plus 2 ones. So this is a /what? 26. That's right, Hamid. And the last one is a /what? Again, 24 ones for the previous octet, plus another 3, it's a /27 network. And that's the easier way of doing all this subnet mask instead of saying all this 255.255.25. We just say /24, /25. But apparently the other part of our colleague needs to be aware of what a /something is. Okay. Let's go to this. So this Cidr notation is just another way of communicating the subnet mask. It's just not anything too technical. Default gateway. Default gateway is the third component of the network information. What do I mean? If you go to your local, to your laptops or to your computer's network card, it needs at least 3 pieces of information to be able to operate in the network. The first piece of information it needs is an IPv4 address. Okay, sorry, just to make sure we're not going to touch any IPv6, okay, in this webinar. It's all about IPv4. So your network card needs an IPv4 IP address. Let's say, for example, because it's our home computers, 192.168.0. Let's say 10. Okay. The second piece of information apparently it needs is a subnet mask. Subnet mask. And as you've seen before, the easiest of all the subnet masks, and that's why our ISPs are using them in our home routers, is a subnet mask of 255.0. And again, as we said before, this is a /24 network, but our network cards need it in this form. The third piece of information is the default gateway. And this is, we're going to talk about this now, default gateway. What is the default gateway? The default gateway, it is the IP address of the subnet's router. This is the device. It has to be on the same subnet as all the client devices. Let me explain. As I said before, in networks, we use this circle with the cross to represent the router. And this symbol is for the switches. In a corporate network, okay, in our home, we've got the router and that's it. Okay, and it's the same subnet. We just don't care about separating our devices to different subnets, unless you have got a very special, I don't know, network at home. In the corporate environment, though, we have got, let's say, one router and multiple switches. This subnet here, 10.0.1.0/24, okay, let's say it's the IT subnet. This other subnet, 10.0.2.0/24, is the research subnet. These two subnets will never be able to communicate together, will never be able to ping each other, let me use this technical term, because they are different subnets. A device here, let's say of .20, will never going to speak to the other .20 here, unless we configure the router. And the router has got this interface to face this subnet, and this interface to face this subnet. What does it say here? It has to be on the same subnet as all the other client devices. Why? As I said before, this network, this range, will never going to speak with this range, with any other range. So this very, very, very specific interface on the router needs to be part of this subnet. And usually the first host of the subnet is dedicated, is assigned to the router interface. So this IP address 10.0.1.1 is going to be assigned to this interface, and this is my router, which means This is my default gateway for this subnet only. What will be this interface's IP address for this subnet, which is going to be the default gateway? Can you pop it in the chat? What should I write here? 10 dot what? Yes, yes, Anil. 10.0.2.1. Because this needs to be part of this range to play the role of the default gateway for this network. And this plays the role of the default gateway for this network. And how are these two going to communicate? The router is a very special device because all the subnets it knows about, it's able to link them together. So my router knows about this subnet, and is going to be able to send to route packets from this subnet here and from this subnet back here. This is the router's job to do, route packets, okay, to different networks, different destinations. Could you answer this question then? What will be if my laptop at the moment is on this network and has got this subnet mask? What is more likely that my home router IP address is? What is my default gateway at home? Let me start writing it. So it's going to be 192 because I need to be on the same subnet. Yes, Gary, 192.168.0.1. Okay, it hasn't got necessarily to be the one, but it's usually number one. Okay, it might be the last one. So the last one is 254. Let me make a note here, an asterisk. We're talking about ranges and capacities and highest available IP addresses and the subnets. Let's say a subnet of 10.0.0.0, and we said if it's a slash 24, it goes up to 10.0.0.255. Let me tell you something here. This first IP address of the 10.0 cannot be assigned to any client devices because this is the network IP address. Okay, we won't be able to assign this IP address to any of the client devices. And this last, the 255, again, it will never be assigned to any client devices in the network because this is the broadcast IP address, broadcast. So the client IP addresses, the usable IP addresses for clients will start from the .1 and will be up to .254. And this is likely, so the .1 or the 254 is going to be my router. As I said before, it's more likely to be the .1, okay? But don't get it wrong if it's the 254, okay? Again, it's usual, but more likely to be the one. And now it's time for me to share my resources. And if you want to just grab a screenshot of this, okay, allow me to unshare this window because I would like to show you these two tools. This is a nice article about all the things we talked about today. So if you would like to see it in a written form with more examples, if you jump to this very nice, very helpful resource, it's all written there. Let me stop sharing this screen now and let me share this screen here. Okay, Hopefully you can see my screen. Let me show you. Okay. Yes, Javier. Yeah. Let me put the URL here. So let me the first one is this one. I'm going to show you what this does, but the examples and the article is here. Okay, so this is my laptop, and let me also let me type the command. It's ipconfig slash all. So this is the command I'm going to type in here. This command allows me to see the network information my computer uses to communicate to the network, to connect to the network. So ipconfig slash all and hit enter. Don't be scared from all of these numbers. What we need, so I'm connected to the wireless network, as you see here. So my Wi-Fi, my wireless adapter, network adapter, at this moment, can you see, this is my MAC address, and this is IPv6, so don't get scared by all these numbers here. IPv4 address, this is my IP, my computer's, my wireless IP address on my home network, 192.168.1.112. Okay, what is my subnet mask? 255.255.255.0. What does this mean? This means that the range of my home network is 192.168.1.0 from 1.0 up to 255. And my default gateway, as I said before, is usually the first host of my local subnet. So my computer is connected to .1.112. My router, my default gateway is .1.1. Okay. And another bunch of information. So the DHCP server is my router. Can you see it's the same IP address? So my router is also my DHCP server, and my router is also my DNS server, okay, which is more likely to be your home configuration as well. And let me show you the other resource. This is the tool I was talking to you about. If you put any IP address here, so let me give you an example. Let's go to the 10 network, 10.0.0.17, let's say. Okay. And it's not, let's say, a slash of 24, because we can all calculate this very easily in our minds. But let's put another subnet mask. Let's do it a slash 23, for example. We didn't go upwards. And I hit calculate. You can see here the IP address is 10.0.0.17. The subnet mask is 255.255.254. Why? Because I needed 23 bits of binary ones. So it's 8 binary. Can you see here? 8 binary ones, 8 binary ones, 7 binary ones here. This 0 is included. Okay, 7 binary ones here make the decimal number 254.0. So this is a slash 23 because I need 23 ones. Wildcard we're not going to talk about. So my network is 10.0.0.0 slash 23 network. And as I said before, the broadcast IP address is the very last IP address of the range. Minimum host, this is the first usable IP address for a client device in the network. This is the maximum, the highest IP address. And my network, the capacity is 510 devices, and it's a private network. Okay. Let me give you another example. Let me give you a public IP address. So let's go to 8.8.8.8, and let's make it a /8. No, it's big, very big. Let's make it a /29. So can you see the IP address is this one? Subnet mask, so it's /29 is 29 ones and only 3 zeros. Okay, and this is the subnet mask of a /29 network. The broadcast is the last IP address of this subnet. So can you see my first client, let's say server, because it's a public IP address. Okay. My first server, I'm going to put it on the .9. My last server, I'm going to put it on 14. So this network is a very, very small network, only capable of holding 6 devices connected to it. And you can see it hasn't got an information for a private network here. So it's public IP address.